Good afternoon. My name is Rebecca Young, and today I will teach you about effective practices for teaching high school chemistry. What is chemistry? Chemistry is the branch of physical science that deals with composition, structure, properties of substances, and with the transformations that they undergo. There are many challenges that accommodate teaching chemistry. For starters, students are sometimes apprehensive about their ability to excel in the course. They hear the title, and many times students lose faith in their abilities. Biology is the current prerequisite, but physics would be a much better prerequisite for chemistry. Chemistry requires daily practice. It's a course based on building skills and not just learning facts. Because biology is the prerequisite to chemistry, many times students get comfortable with learning by memorizing many facts, and there is also very little math involved in biology. However, chemistry is a course where skills like nomenclature, electron configurations, balancing reactions and chemical equations, predicting products, calculating percent yield. These are all skills that have to be built and practiced daily. They're not facts that you can just learn. Patience is needed with the learning process. It's very easy to get frustrated. And students have no choice but to cultivate a very high order of thinking skills. More analysis and synthesis is involved. Teaching chemistry requires enthusiasm. Students need to get excited about a subject that their teacher is excited about. Practice. We mentioned practice in the previous screen, but daily practice is definitely necessary. Chemical demonstrations. Mini lectures. Math instruction. Visual aids and three-dimensional visualization. And hands-on experiences. I think the hardest part about teaching chemistry is breaking down complex and many times abstract concepts into a level where students can grasp. Teachers will definitely need to integrate multiple hands-on activities wherever possible. To accomplish all of this would be to teach chemistry successfully. And quite simply, this involves an effective strategy, such as the 5E instructional model. What is the 5E instructional model? This is a model that was developed by the Biological Sciences Curriculum Study. It's a learning cycle. In this cyclical process, it is based on the notion that learners bring preconceived ideas about how the world works. In education, we call this constructivism. The 5E models provides a planned sequence of instruction that places students at the epicenter of their learning experiences. It encourages exploration and for them to construct their own scientific concepts and relate those understandings to other concepts. The 5 E's stand for engage, explore, explain, elaborate, and evaluate. The purpose of the engage stage is to capture the student's interest. What you're looking for is a wow factor. The goal of the teacher is to instantly grab the student's attention so that they anxiously anticipate your next move and they're eagerly listening. Any activity that intrigues students' curiosity is sufficient. Here are some ideas. Demonstrations that have a wow factor, something that goes boom, explodes, oozes, or smells funny. These are all great demonstrations of engagement activities. Maybe you don't have a demonstration to perform. Reading something that has an exciting hook, playing a short video that keeps them on the edge of their seats. Anything that inspires a wow from your students. The next step is to explore. Now that you've captured your students' attention, what do you do next? The purpose of the explore stage is to provide hands-on experiences. This is to hold the student's attention long enough so that they can process a skill or a concept, and that can be formally introduced. In this stage, teachers provide students with concrete experiences that help them begin the construction of concepts and skill development. For example, you can have the students build models. It doesn't have to be fancy, just something that involves their hands. Students can collect data in an activity or a lab where they are actively performing that lab. Students can make and test predictions, or students can form new predictions, all while actively performing that lab activity. These are all excellent examples of exploration activities. The next step is to explain. We definitely want to have more than just capturing the students' attention and giving them something to do. The explain stage is critical. Here is where teaching and learning is actively taking place. Learners articulate their ideas using their own words and listening critically to each other. The role of the teacher is to observe and listen. The teacher must clarify concepts, correct misconceptions, and introduce scientific terminology. How is this done? Here we can integrate several familiar learning strategies, such as think, pair, share, where you can have students share their active knowledge with one another, their ideas about the content or their beliefs. Then they can turn and share this with their peers. Think, pair, share is very similar to turn and talk, except that turn and talk would be after you've shared with those in your group. You turn and share with another group. Let's say the teacher doesn't want to do small group work. She can facilitate a class discussion, and this would involve the entire class at once. Perhaps you want to do something nonverbal, or that's only partially verbal. Then you can explore reflecting and sharing, and this would be where the students would write about their ideas or the things that they've learned. They can reflect on a piece of paper and then share that verbally with the class. These are all ways to explain. The next step is elaborate. Elaboration activities allow students to demonstrate deeper understanding of the concepts. In this phase, students are challenged to apply, extend, or elaborate upon concepts and skills in a new situation. And that's the key here. The situation has got to be new. They're bridging, if you will, what they understand with what they can understand. Elaboration activities allow teachers to dispel misconceptions that students may have and expand their understanding of the concepts in the previously introduced exploration phase. Here are some examples of elaboration. Students can apply new labels, definition skills, and explanations in new but similar situations. Students can use previous information to ask questions and propose new solutions. Students can use previous information to design new experiments and make new decisions. In other words, this is bridging what they just learned with what they think they understand. And the final step is evaluation. In the evaluate phase, teachers evaluate students' understanding of concepts and their proficiency with various skills. This phase also provides an opportunity for students to test their own understanding and skills. And this can be done in many ways. Students can answer open-ended questions posed by the teacher using evidence, observation, and previously accepted explanations. Students can demonstrate understanding through traditional means with a summative assessment such as a quiz, a lab, or a lab write-up. Feel free to integrate modern technology such as Kahoot and Quizlet in these forms of evaluations. There are never any guarantees with teaching strategies, and teachers must choose the model that works well with their classroom dynamic. If you feel this model won't be as effective in its totality, consider adopting areas that do work and incorporate them into your classroom lesson plan. Research has proven the 5E model to be a successful method for not only teaching physical science, but making the learning experience fun. Here are some of the work cited for my presentation today. Thank you for viewing, and I hope these instructional techniques will be of assistance to you as you begin practicing teaching your high school science classes.